Let's look at OpenStax University Physics Volume 2, Chapter 7, Problem 52. Find the potential at points P1, P2, P3, and P4 in the diagram due to the two given charges. So we have a plus 5 millicoulomb charge and a negative 10 millicoulomb charge, and we want to find the potential at points P1, P2, P3, and P4. So really the puzzle is to figure out all these distances that are just written all over here. Now, before we do that, we have to remember two things. The potential is given by K, Q over R, and it's a scalar quantity. So that means that we'll never draw vectors for potentials. All we're interested in is the strength of the charge with the sign. So you see that this Q is not an absolute value, so we're going to use plus or minus, depending on what the charge is, if it's positive or negative, and the distance from the charge to wherever the point is that we want to solve for the potential at. So for part A, for P1, we want to know what the potential is at this location. That means that we're going to add the potential from this charge to the potential from that charge at this location. Now, this location has a distance x1 from, I'm calling this charge q1, and this distance is actually 4 centimeters minus 2 centimeters. So that is my first distance x1, and it is 2 centimeters. So I will do it this way. I'll say point P1, I have a distance x1 of 2 centimeters. And let me write here Q1, this is Q2. I'm not going to label x1 and x2 on the diagram because there will be 4 of each. Now the distance x2 is the distance from this charge to point P1. So this much is 4 centimeters, and that is 2 centimeters. So that means that this distance is 6 centimeters. So I have x2 is 6 centimeters. So that means that the potential at point P1 due to the two charges is going to be K Q1 over x1 plus K Q2 over x2. So the potential at P1 is going to be, I'll factor out the K, 9 times 10 to the 9th. Q1 is 5 millicoulombs. X1 is 2 centimeters. And to that I add Q2, which is negative 10 millicoulombs, divided by x2, which is 6 centimeters. Now, when I actually do the calculations, I have to convert from millicoulombs to coulombs, so that would be 10 to the negative third, and from centimeters to meters, so that would be 10 to the negative 2. But when I make these calculations, I end up with 7.5 times 10 to the 8th volts. So the potential due to these two charges at that location is 7.5 times 10 to the 8th volts. Now the second one is P2. So again, I need to know the distance from charge Q1 to P2 and from charge Q2 to P2. So from here to there is 4 centimeters plus 2, so that's 6. So I'll say here's P2. We have x1 is 6 centimeters, and x2 is a distance from here to there. So that is 4 minus 2, 2 centimeters. So that's 2 centimeters. We'll use the same equation. So we basically add the potential due to charge 1 to the potential due to charge 2. So we end up with potential at P2 is 9 times 10 to the 9th. Again, I'm factoring out K. And the charge is 5 millicoulombs divided by the x1, which is 6 centimeters, plus negative 10 millicoulombs divided by 2 centimeters. and that will be negative 3.75 times 10 to the 9th volts. So while potentials don't have a direction, they can be positive or negative. So here we have a negative 3.75 times 10 to the 9th volts. All right, now point 3 is down here. So we want x1 is the distance from charge q1 to point P3. So I know that this is 4 centimeters. I know that this is 3 centimeters, so I can use a Pythagorean theorem to solve for that. So here we have point 3, and I know that x1 is square root of 4 centimeters squared plus 3 centimeters squared. So that's a 3, 4, 5 triangle. That's just 5 centimeters. For x2, we want the distance from Q2 to point 3, and this is 4, that is 3. So again, doing the Pythagorean theorem gives us x2 is 5 centimeters. So then the potential at point 3 will be 9 times 10 to the 9th times charge 1, which is 5 millicoulombs, divided by x1, which now is 5 centimeters, plus charge 2, that's negative 10 millicoulombs, divided by x2, which is also 5 centimeters. And that gives us negative 9 times 10 to the 8th volts. Now for P4, the last one, we want a distance from Q1 to P4 and from Q2 to P4. And again, this is 4, that is 3, that makes it 5. This is 4, that is 3, so this is also 5, which means that the potential at P3 is the same as the potential at P4, and that's negative 9 times 10 to the 8th volts.